All right, let's take a look at today's assignment. We're starting with a warm-up of the stuff we did in the first week of school. This was getting us ready for this section and the next section when we're going to be doing simple interest and compound interest formulas. But let's get started. Michelle decided to put some money in a bank account to earn interest for a couple years until she wanted to buy a car. If she put $7,500 into a savings account for 3 years that earned 2.5% interest, how much will she have saved after 3 years? So we've got this starting amount of $7,500. That's our principal, or the amount of money we're starting with. We've got a time of 3 years. That's going to become our power in this formula. And we earned 2.5% interest. That percentage right there should be like ding, 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 reminding us that we have to go do some work on getting our multiplier. So since it's earning interest, we're using the 1 plus R formula. And it's 1 plus what goes here? Remember, we want to take this take this percent and convert it to a decimal by moving that to the left twice. So 1 plus 0.025 becomes 1.025 as your multiplier. All right, here we go. So now that I've got my multiplier, now that I've got my starting balance and my time, I can go plug into this formula. So it begins with 7,500. 1 plus 0.025, or you can just put in the 1.025 multiplier to the power of 3. We take this over to Desmos to see if I plug this in times 1.025 to the power of 3, how much money would Michelle have after? So that's going to be 8,000. I just put this into my Desmos. $76.68. We're rounding up. Hopefully you got that when you plugged that into Desmos. All right, for the next formulas, if you're doing this electronically, if you're typing into the document, I highly recommend you still go write down any of these vocab words with their definitions that you need. There is a link to Desmos right here on the document. And these formulas are extremely important. In class, I would be giving you this to glue into your notebook. This is the simple interest formulas and all of its manipulated versions that we're going to be using in this assignment today. So make sure you write down these 4 formulas if you have not already as big, bold notes. All right, let's get started on today's examples. So first one, example 1, Lisa has a glass jar in her office that she's going to use to collect coins. She starts by putting $11.25 in coins that she already has. That's her beginning start. She pays for her commute to work each day and receives 70 cents in change. She will add that 70 cents into the glass jar each workday after 100 workdays. She will take all the change and deposit it into the bank. How much will she have after 100 workdays? So first we want to write, back from Math 1, an explicit formula. This is the equation for an arithmetic sequence when I'm going to be adding 70 cents each time. Remember this stuff? And then we're going to evaluate at f of 100. We're going to plug in 100 days and see how much that would be. So let's see if we can remember how to write this explicit for an arithmetic formula. We can just call it f of x. It doesn't tell us a name to use. She begins with $11.25. That's what I start with. And she's adding 70 cents every time she goes. And so she started with this for her commute to work at 70 cents per change. She's going to add 70 cents each time. So we could write x minus times 0 because we're starting at the beginning, or you could just write x. So here's our explicit formula. It begins with this, adding this every time to this. Now, I'm going to go evaluate that function for 100 days. So here I go grabbing my calculator. I'm going to do first the multiply and then the add. I'm going to do 0.7 times 100. And that gives me 70. And then I do 70 plus 11.25. And I get 81.25. So just quickly, looking at how a small amount of money like 70 cents over time can add up to be a good amount of money. So it's not a crazy thing to save 70 cents a day. Look how much you could have. All right, in example 2, Grace wants to deposit $5,000 into a certificate of deposit. That's a type of savings that you can do in any account that you open with the bank. They have CDs or certificates of deposit that you can put in for a period of time. She is comparing interest rates quoted by 3 local banks and 1 online bank. Write the interest rates in ascending order. Which bank pays the highest interest for this 2-year? So some of these are in fractions and some of these are in decimals. We need them to all be in decimals in order to compare them. So first, this 1 1/4. I'm going to take the 1 and divide it by 4 in order to get the decimal. And then I see that that equals 0.25. So this is really a 1.25%. Let's do the same thing with the 3/8. Let's go 3 divided by 8, and that gives me 0.375. So 1.375 is my percent for this bank. So now let's just go write them in order. Which one is the least of all of them? Johnson City Trust. What's the next one? First State. What's the next one? Is 1.30 or 1.375 next? 1.30, and then finally 1.375. So which one gives you the highest? We would say that eSave Bank is the one we should go with. Okay? Next one, Brian's savings account must have at least $500 in it or he's charged a $4 monthly fee. His balance was $716.23 and he withdrew $225. So let's use our calculators and see how much he now has in the account. And he's got $491.23. So he did go under the $500. So what was his balance after the withdrawal? He does get charged $4 fee. So I'm going to take that $491 and subtract $4, and his final balance when I subtract 491.23, and I get $487.23. I hope you're doing these calculations with me. Feel free to pause the video and then start it back up if you need more time on things. All right, let's look at example 4. Adrian deposits $1,200 in an account that pays 1.5% simple interest. He keeps the money in the account for 3 years without any deposits or withdrawals. How much is in the account? So we've got this interest formula that's over on the front page, principal times rate times time. So first, I need to calculate the interest. Then there's going to be a step 2 here that we do in a second. So first we've got principal of $1,200, a rate 1.5% simple interest. I need to convert that to a decimal. So my new decimal that I'm plugging in here is 0.015, and then times the time of 3 years. So I plugged in the principal, plugged in the rate, plugged in the time here to these. And how do I know this is a simple interest problem? It says directly in the problem that it's simple interest. Okay, and now we just take our calculator and multiply all this. So 1,200 times 0.015 times 3. And I'm getting $54. Now, $54 is the interest earned. That's why this was only step 1. It says how much is in the account after 3 years. So to get the balance, I have to take the original amount and add the interest that we earned. So to get my balance, take the original amount of $1,200, add the 54 earned, and we get $1,254 as our new balance. Done. How much simple interest does $2,000 earn in 7 months? Be careful here. All of the times in these formula are in years. So how am I going to put 7 months in time? It's 7 out of 12, or 7/12 is going to be my t in this one. This is the trick. So how much simple interest? It's another simple interest, I equals PRT problem. And so we start with the principal of 2,000, a rate of 2%, and the time is 7/12. Plug that into your calculator. And I get $23.33. How much principal must be deposited to earn $1,000 simple interest in 2 years at a rate of this? So if you just use the regular formula every time, sometimes we're plugging in for a different variable. And so 1,000 is the simple interest we earn in 2 years. There's my time at a rate of 1.3, so 0.013, and we're trying to find P. So if you look back at this formula page, we already have it moved around where P is what we're trying to find. So feel free to use this formula right off the bat. Instead of dividing by these things here, just go ahead and start with the P equals the interest divided by the rate times the time. And that will give you your answer straight away. So these formulas we've already manipulated for you can save you time. So 1,000 in my calculator divided by parentheses 0.013 times 2. Oh, that's a lot of money. 38,461 and 54 cents. It's a big number because to earn interest of $1,000, you have to have a lot of money in the bank to do that, especially at such a low rate of 1.3%. All right, last two examples. Olivia has a bank account that pays 2.1 simple interest. The balance is 910. When will the account grow? When it asks for when, it's looking for time. So this time I can go back to this little cheat sheet of time is equal to interest over the principal times the rate to save me time on the formula. It's already been manipulated for you. So how long? So this time we take the rate of 2.1, bump the decimal twice, 0.021. That's going to go on the bottom. The balance is 910. That's my principal. And when will the account grow to $1,000? There's my, oh, this is a sneaky one. $1,000 minus the 910. That's really only a $90 interest. See how they snuck that one in there? So 1,000 minus 910 is really going to be 90 divided by 18.2. Oops, forgot a 1. 19.11. And so that's 90 divided by 19.11. So 4.7 years is how long it would take for the account to grow to $1,000. Okay, finally, last one. Enrique invests $5,000 in simple interest account for 5 years. What interest rate must the account pay to get $6,000 at the end? So rate equals, so where we have 5,000 in a simple interest account for 5 years to get 6,000 at the end. So 6,000 minus 5,000, that's going to give us the interest earned of $1,000. And then what interest rate must the account pay? We're solving for R at the end of 5 years, and at the bottom is my principal times the time. So 1,000 divided by $25,000. And that's 0.04. So that's a rate of 4% that would be needed. Notice how using these equations when they're already manipulated for you for the variable you're looking for can save you time.